So I have one more, last chance, going, gone. That's it. The gentleman at the back, you're on. Can we pass a mic to him, please, as quickly as we can? Please keep your hands up, sir, so that they can see you. A mic to the gentleman at the back, sir. That one, that guy there. The microphone, please, guys. Yeah, anyway.
All right. My name is Michael City. I work with Kiss FM Lagos, and also I play TV. So I hear IPs. I also hear clouds. So my question is, what's the difference between what you have right now with the Sony and Live View, with different from what we have on streaming via OBS on YouTube and Facebook Live as well? Because from everything you've said, it's cloud-based. So if it's cloud-based, so my question is, what's the difference? What would Sony and Live View do different from when we stream via YouTube Live or Facebook Live using the OBS as a major studio? So that's just the question I want to know.
Actually, the difference is the technology, and with our solution, what we are bringing in is more of the quality and reliability. So we want to bring the broadcast quality that you normally get from using a normal OB van into this space whereby we are using IP and streaming. So there are challenges there. The first challenges you find, like when you're using things like OBS, you have a challenge of encoding because you're using maybe your laptop that maybe doesn't have enough processing capability to be able to process, to encode a video. So you can have some quality challenges. So with our solution, it's 100% hardware-based encoding, which assures, and with enough resources to ensure like it can be able to process any kind of video. Secondly is on the connectivity. So maybe your OBS is running on one laptop with one connection or two at most. So with our technology, we enable you to have even, to aggregate up to even 12 connections. So you get enough capacity to be able to stream a high quality video up to 4K using the same IP or cloud-based or cloud system. So those are the difference.
Thank you very much. Can we give Raphael a round of applause for a well-presented presentation? Thank you. That's from Live View. Okay. All right, let's move on. Now we go to the final masterclass session, which is, there was a gentleman asking me a question about this. This is the one you are talking about, okay? Sorry, I was in a bit of a rush when you were asking me. You know yourself. This is the one we're talking about. So now we're going to be looking at connectivity and media delivery solutions, understanding and implementing SRT IP video transmission. Understanding and implementing SRT IP video transmission. And to give this masterclass is HAIVISION. Who is representing HAIVISION in here? HAIVISION? Is HAIVISION here? They must be here. All right. Florin, are you ready? No, it's not ready. Whilst he's setting up, it's time to give you some information and announcements. As you know, well, if you don't, you will know now, the conference will finish soon. Then we will have a break, and then we will all, well, we won't all come back here. It was going to be by invite-only basis if you have the card. We have the gala night, which is my favorite part of the day now, because now we're going to have music, lots of food, lots of drink, whiskey, brandy, wine, plenty of wine, more wine, and you will also have the DJ and the comedian. It's gonna be awesome. Don't miss it. If you haven't registered, obviously, you will need to register for it. But I don't know if they're still taking people, but we'll find out. That will start at 7 o'clock, 748. And we'll be here till 10, and then there will be after parties afterwards. And also, yes, today. It's today. Yes, this evening. And also there is, obviously, the networking hub from SES. I've been asked to remind you that. For those of you who wants to have finger food and drinks and meet with your colleagues there. Are we ready for HAIVISION? One more minute. People that want to have something to drink and eat and network with people. And that will be there till about 5 o'clock. The actual exhibition will end at 5 o'clock. 5 o'clock, people will start packing up, and hopefully, I need to talk to my principals about this. Hopefully, we will do this next year. Who wants Africa to happen next year? See, that is what I said. We want it to be an annual event, right? And that is what we are aiming for. Normally, as you know, it's always been biennial, but we want to make it annual. Why do we want to make it annual? Because for those of you that goes to the calendar events, the one in Las Vegas, the one in Amsterdam, the one in Dubai, Capsat, Las Vegas, I think they call it NAB. Amsterdam is IBC, and even the guys of content that go to MIPCOM. These are calendar events. They happen every year. So the people know at the beginning of the year, they will say, yes, that one, we have to be there. And if we're going to have a calendar event for broadcasters in Africa, it should be in here, in Lagos, in Nigeria. That is why we are going to be trying to push to make sure that Africa has a new face now, and Africa should be an annual event. So we're looking forward to announcing very soon, subject to the blessing of the DG, the new DG of NBC and the NBC staff, the dates for Africast next year, or upcoming Africast. Florian, I see you are approaching. Are you ready? Yes. Now, there it is. So we're going to be looking at connectivity and media delivery solution, understanding and implementing SRT IP video transmission. And nobody else to do this than my very good friend, Florian Colmer. Can we please appreciate Florian Colmer, please? Florian, there you go.
Thank you very much. Thank you. Welcome again, everybody. I'm sure some of you have been spending quite a lot of time here listening to all those interesting topics. I hope you still have some energy to follow this one. So this one will be about connectivity and live video transmission for many different workflows and use cases. Just to start with, I wanted to introduce you HAIVISION. HAIVISION is a Canadian company that you may be aware of, which is famous in the field of live video transmission for contribution and distribution over IP for both broadcasters, production companies, teleports, satellite operators, and so on. So it's a company based in Montreal, but it has a global presence all across the world. Can you put the next slide, please? So quick history about this, but if you are interested in those slides and to have all the information, there will be my contact details at the end of the presentation, and you will be able to send me an email or a WhatsApp message to get the presentation. I will be happy to share it with you. So over the years, HAIVISION have been growing and is very famous. Maybe you are aware about the SRT protocol. The SRT protocol has been invented by HAIVISION more than 10 years ago. The target of that protocol that we have been inventing is to provide a reliable and secured protocol for live video transmission over IP and especially over public networks. It's designed to provide a secured and reliable solution to replace technologies like satellite uplinks, dedicated fiber, dedicated internet links, to leverage the use of the public connectivity offered by landline internet, whereas it's fiber, DSL, or whatever you have. So after that, a few years ago, now that's 5-6 years ago, HAIVISION made the SRT protocol open source for a wider adoption. So that was a big step for HAIVISION, and the SRT protocol became the #1 protocol for video contribution over IP. It's now part of an SRT alliance that we created, where there are more than 300 members. I will show it to you later. More recently, HAIVISION, it was last year, acquired a company called AVIwest. AVIwest is well known for bonded cellular video transmission. It allows you to contribute live video content from camera or the output of a mixer from a venue, from the field, even on the move if you are covering a marathon, cycling, or any kind of event like this, by using multiple cellular connections. So here it's like a small presentation video. I'm not sure you have the audio, but about HAIVISION. Yeah, thank you. Okay. Sorry, I thought there was the audio, but it's okay. So to get a bit deeper into the ecosystem, here's what we are offering for all your needs in live video streaming. So our technology is composed of different protocols and different products, which are always offering you a solution for your live contribution needs. So it can be used for news, it can be used for sports, it can be used for entertainment, it can be used for house of worships as well. Everywhere you will need to send a live video feed to a studio for production, and also from that studio, all your need of distribution, whatever it is, destination to satellite, IP, online streaming platform, YouTube, and so on, you name it. So we are offering two different kind of technologies for live video streaming. The first one I was mentioning is SRT. SRT stands for Secured Reliable Transmission. It's a protocol I was mentioning, which is designed to live stream video feed over the public internet using a landline internet connection. So it can be used for both contribution. Let's say you are covering an event from a stadium, you have multiple cameras, you want to home run all those camera feed into a remote studio for production. That can be used over SRT with a landline internet. Then in your broadcast studio, you can do the production, and you can also use SRT to distribute your final feed for satellite, IP, online streaming, television in general. So, can you just leave back the previous one? I didn't finish. Can you put back the previous slide? Yes, thank you. The second technology of HAIVISION is a protocol which is called SST, for Safe Stream Transport. It's a protocol which is designed to transmit live video over cellular networks. So if you are covering an event in a venue where you don't have any landline internet available, or you don't have a reliable landline internet available, with that protocol and that technology, you can use publicly available 3G, 4G, and now 5G networks as well to send your live video feed into your broadcast studio. The particularity of this technology, SST, is that it's capable of bonding multiple SIM cards from multiple providers together to give you more bandwidth, a better coverage, and a better reliability, while maintaining a low latency, which is really required, especially for remote production, I will speak about later. So the first part of the presentation is more focused on SRT, and the second part will be more about bonded cellular with SST. So SRT is a protocol which has been designed initially to offer another solution to satellite uplinks to reduce the cost, make the transmission more reliable with higher bandwidth and lower latency. So if you are used to satellite uplink from a venue, a stadium, or a conference room, to uplink the signal back to your station or back to a teleport, that can be now easily replaced with the SRT technology over IP. It can also be used to connect your regional, can you just stay to the previous one, please? It can also be used to connect your regional stations, for example, to the main headquarters. So let's say you are having regional station in different states and different cities, and you need to send all your program feeds to Abuja, for example, or to a teleport. You can use SRT. It's designed to be reliable 24/7, 365, to contribute from regional station to the main headquarters or to a teleport. That's the last one I was showing here. It can be used to broadcast your program to the satellite teleport, for example, but also to online video platforms over IP. Can you just move to the next? So here you have a small video about SRT. Now for a few years there is an alliance called SRT Alliance, in which most of the broadcast manufacturer, broadcast player, online platforms are part of this SRT Alliance, which means there is a full interoperability between all the SRT products available on the market, whereas it's encoder, decoders, distribution platform, cloud production platforms. Here you have a few interviews, but sorry, you don't have a sound here, about some of the SRT users for different use cases, for production, for distribution, for contribution here. Can you move to the next slide? Okay. So here you have a small schematic about the SRT workflow. So typically in an SRT workflow, you want to send an SDI signal, for example, to a destination. The destination can be a remote production studio. The destination can be a satellite distribution teleport. The remote destination can be an online streaming platform, whatever it is. So for that, you will need, at the first step, an SRT encoder, like for example the Makito X4 encoder I will show you later. And then you can stream SRT over the public internet. It's capable of doing path redundancy, to have a redundancy between two internet providers for more reliability. You can have multiple destinations. You can even have in between, like you can see on that slide, a gateway which will distribute your content. So let's say you want to distribute your program to multiple destinations, but you don't necessarily have enough internet bandwidth at the venue. You can just send a single feed to an SRT gateway in your headquarters or in the cloud and distribute the feed from that location to all the destinations. What's mentioned here and important is that apart from being a secured and reliable protocol for live video transport over IP, it's also a low latency solution. So it means you can achieve a live transmission end-to-end with low latency, like 50 milliseconds, 100 milliseconds, depending on the latency of your internet connection. So here it's about the SRT protocol itself. I've been mentioning low latency, secured streams. It has also some functionalities for firewall traversal, which needs, you won't necessarily need to have a public IP address in your connection or to open some ports in your router. So it has some firewall traversal capabilities. It's content agnostic. So it can be video, any codec, it can be audio, it can be metadata as well. It's a transport protocol, a transport mechanism. And down here, it's showing a bit what it's aimed to replace and offer a better solution. It can replace satellite, as I was mentioning, with a more effective way and more efficient way to transport live video feeds and lower latency. It can also replace some other IP protocols which were available before, like RTMP or HLS, which are not really designed to be used over a public internet connection which is not guaranteed. So SRT here is providing a more reliable transport mechanism with mechanisms like packet retransmission, error correction. And it's also designed to maintain a constant latency. That's key if you are moving into a remote production workflow, is to receive all your camera's feeds into your remote studio with a constant and fixed latency and full genlock. So that's what SRT is enabling. It's also enabling cloud workflows. We have more and more partners developing cloud production platforms, which SRT is a perfect protocol to ingest the feeds for production in the cloud. Okay, apart from that, I didn't mention it, SRT is also capable of securing your transmission, which can be encrypted. So if you are producing some content, especially sport content, and you need to secure your transmission because you have some rights holders and you need to protect that content. With SRT, the full transmission can be encrypted with AES encryption. Can you move to the next one, please? Okay. So that's for the transmission. Then we have some distribution platform available. As I was mentioning in the intro, it's called the SRT Gateway. If you are producing content, you are producing any event, sport, entertainment, whatever it is, and you want to distribute it to multiple destinations because you are streaming it over satellite with multiple satellite distributors, you want to distribute it over IP in different countries, and at the same time you want to distribute it on online platforms. We have a solution called the SRT Gateway, which is capable of receiving all your program feeds at the same time. You have no limit on the number of feeds, and distribute it to multiple destinations over IP. So it's called SRT Gateway. It's a solution which can be either hosted physically in your premises, in your teleport, in your headquarters, for example, but it's a solution which can be also hosted in the cloud. It's available as a service, for example, in AWS, Azure, or Alibaba Cloud, for example, or as a virtual machine with VMware. So here you have a small overview about the interface of that SRT Gateway. It's a web-based interface where you can manage all your video routing in a very easy way and remotely from any web browser, and you can create and monitor all your routes and video transmission. As I was mentioning in the intro, SRT has been widely adopted. So now you have a few examples here of companies who are compatible or integrating or using SRT. It can be public clouds. I was mentioning just on the previous slide that the SRT Gateway is available on AWS or Microsoft Azure, for example, or Alibaba Cloud. So public clouds have been integrating the SRT technology. It can be also streaming platform. Recently, YouTube joined the SRT Alliance, and now it's possible to send an SRT feed straight to YouTube. It can be media services. You probably all know companies like Eurovision or Comcast or Tata who have been standardizing over SRT for all their live video transmission. Can be broadcast vendors, from cameras to switches to software-based or hardware-based solution, and also some open source projects as well. So I've been explaining a bit more technical how the protocol is working. I see some of you are in the audience who are looking to understand more about how it can be used, how it is being used already in the field. So that's the second part here. Different workflows which can be addressed with our technology. The first one is when you are covering live events, sport especially, but not only sport, for production. Then I will explain more about our bonded cellular solution for locations where you don't have any landline internet available. And I will finish that part by showing some remote production workflows and understand how easily you could potentially move some of your production into a remote production to be able to produce more live content, reduce the costs, and be more efficient. So to start with, here you have a quick video showing a live event across 15 countries produced in a central location. So that was made, it was an e-sport event, which was in 15 different countries like Japan, Korea, China, Europe, US, across the globe. You can see it here. And the production company, Riot Games, wanted to produce all the content from the 15 locations live at the same time and distribute it for TV and OTT in all those countries. So to achieve that, they made a central studio in Los Angeles that you just saw on the previous part of the video. And they were receiving 24 feeds from 24 cameras per country, per venue, over SRT, over the public internet, producing the content and redistributing the live program to all those countries for TV and OTT. So that's an example on how you can use this technology. It was very interesting because it's much easier to deploy and much more cost effective than using satellite uplink, while having a much lower latency for production. Can you move to the next slide, please? Sorry about that. Yeah, thank you. So that example with Riot Games is what I used to call fixed remote production, meaning the event is happening in a fixed location, like in a stadium, in a venue, in opposition to what I'm calling mobile remote production, where you are covering cycling or a marathon and your cameras are moving. So here in remote production with fixed feeds, you can use SRT and encoders like the Makoto X4 encoder, which was used by Riot Games, over a landline internet connection. And at the venue, you connect all your cameras, and you receive all those cameras feeds remotely in your studio, in the previous example in Los Angeles, for example. Here you can see what the encoder look like. So one of the main solutions of HAIVISION is the Makoto X4 video encoder. It's an ultra low density solution, which is very compact, which can encode 4K UHD video up to 4K UHD in HEVC or H.264 with an ultra low latency in 4228 bits HDR. And it's available also in a 1RU or 4RU chassis if you need to put more than 4 channels encoder. So it's a very small density product. You can have a 1RU encoder with inside, so in a 1RU rack mount space, you can encode 24 HD channels. So that's a really small and high density solution. Everything can be remotely managed, so that's key as well. If you are doing this kind of remote production, you want to reduce the number of people you need to send on site. So for this example, you can just send cameraman, a technician who will set up those encoders, connect them to the landline internet and to the cameras, and then from the remote studio, you can remotely manage all the encoders. Here you can see a small view of the interface. It's a web-based interface where you can monitor all the video sources, all your cameras, and audio as well, and it's very easy to use and to operate. Can you just move to the next slide, please? Okay, so what's key in here is when you are doing live video transmission over the public internet, you will tell me, yes, but the public internet is not necessarily reliable, and it's true. So what we have been adding in the SRT protocol recently is a functionality which is called path redundancy. It means you can use two internet providers, two different providers, that's what we are recommending, connected to the encoder, and the encoder will do a full redundancy on the transmission, sending all the IP packets and video feeds to the two internet providers. So even if one is failing, you will still receive the video with low latency on the other side. So that's called path redundancy. Then that's another workflow. If you are doing a mobile remote production, let's say you are producing a cycling event or a marathon, for example, of course, the previous workflow doesn't work because you don't have landline internet along the road. So the other workflow we are offering is remote production over bonded cellular. So instead of having a rack mount encoder at the venue, you will have a small device which can be mounted at the back of a shoulder camera, or it can be carried in a small backpack. This device will use all the connectivity available in the location. It can be 3G, 4G, Wi-Fi, 5G as well. The idea is to make it reliable and high quality by bonding as many 3G, 4G networks you have in the location. So for example, here in Nigeria, we are usually recommending to use multiple SIM cards from NTN, Etisalat, Spectranet, Smile. We are supporting all the 3G, 4G, 5G frequency bands available worldwide. So in this kind of device, you plug all the SIM cards. It's very convenient if you are traveling because it's easy to change SIM cards. You plug your camera, and you will receive the feed in high quality, low latency in your remote studio as well. So that's a perfect solution to cover cycling, marathon, running events, for example, because you can have this device at the back of the camera or in a small backpack on a motorbike, and you can have as many as you want. If you want to cover the event with 4, 8, 12, 16 cameras, you have no limit, and you will receive, that's a device, and you will receive all those live feeds perfectly gen-logged, frame accurate into the studio. Here you can see one of those bonded cellular encoders. That's a Pro 460. It's a 4K UHD or multi-HD for HD channels encoder, HEVC for 2 to 10 bits with HDR. And you have a lot of additional features in this technology because you can have duplex intercom, so you can communicate with the cameraman in the field or with a journalist if you are doing news. You can, of course, record, and you also have capabilities like video return, so you can have a video return feed from the studio to the field. It can be a teleprompter if you are doing an interview. It can be the program feed for monitoring. It can be a multi-view with all the cameras if you have someone in the field who need to follow the production. It can even be a video return feed, which is a final program you want to broadcast on a large monitor. So in the example I was mentioning, if you are covering, let's say, a marathon, you have this equipment on multiple motorbikes with cameraman. You are doing the production remotely in a studio, but you want to show the live program in the finish line, for example, which can be in a remote area. With that device, you can send back a full HD feed live from the studio to one of that unit in the field, and you have an HDMI output. You can plug a large monitor. So that's here showing quickly all the capabilities of this unit. I've been mentioning some of them, not necessarily all of them. You have another one which is called Data Bridge, which allows you to remotely control IP cameras, for example, from a remote studio. So that's for a different workflow. It doesn't work for cycling or marathon because you will need a cameraman in that case. But if you are covering something fixed like basketball or boxing, you can put fixed PTZ camera in the venue, and the cameraman can be remotely control those cameras. Yeah, thank you. So then we have different kind of bonded cellular encoders. Some are single HD channel, some are multi-HD channel with 3G, 4G, 5G modems, different number of modems from 2 modems to 8 modems, depending on your needs. It can encode up to 8 audio channels as well. That's a request I have been having here at the exhibition over those few days, is how many audio channels you can encode in this technology. With the bonded cellular products, 8 audio channels. With the fixed SRT encoder I showed before, the Makitos, you can encode 32 audio pairs. So that's interesting because you can pass multiple languages, for example, or multiple audio channels. Here you see how it is working. With bonded cellular, it's not only cellular. It can bond any kind of internet connection. So here you can see it can bond 3G, 4G, 5G, but it can bond Wi-Fi, it can bond landline internet, and it can also bond IP satellite. And this technology around SST is capable of bonding heterogeneous network. So you don't have to choose between cellular or Wi-Fi. You can bond them together, and you can even bond cellular with IP satellite like Starlink. If you are in a remote area with low cellular connectivity or no cellular connectivity, you can use satellite transmission as well. That's showing quickly what the SST protocol can do. It can do live transmission, live video transmission, full duplex intercom, as I was mentioning, video return, data bridge to remotely control IP equipment, but it can also pass any IP data, so it's completely agnostic to the use case and the equipment you are using. Here you see a bit of pictures, what this device looks like. If you are coming on our booth later, you can have a look on them. The Pro Series, for example, is designed to be mounted on V-Lock or Anton Bauer cameras. It can be also carried in a small backpack. The air unit can be carried on a belt with a smaller camcorder, for example. Then I've been mentioning a lot about hardware solutions. Here it's now the turn of software solutions. If you need, for some of your production, you don't necessarily have cameras or a cameraman on site, whatever it is, news or sport. We also have a software-based solution called Mojo Pro. It's an app for smartphone which is working under iOS and Android, so virtually all the phones you can have. We recommend to use a more recent phone to have a better video quality. And this is an app which is freely available on Apple Store and Google Play, which will turn your smartphone into a live production camera. So it is having professional capabilities. You can do white balance, manual focus, ISO, reticles, you have audio meters, and so on. And you have the bonding capabilities as well that you have with the hardware encoders. So it means you can bond two 4G networks, for example, together. And you have similar functionalities. You have duplex intercom, so you can do duplex interviews. You can have a video return feed from the studio as well, directly on your phone. So it's giving you all the capabilities of a professional camera into a single phone. Of course, it's not designed to be used by carrying the phone in your hand. It's designed to be used with a tripod or a gimbal, with an external mic, an external earpiece, maybe some light. But you can carry all those equipment in a small backpack and be quickly on stage to produce content. So it can be used for news, of course. Can you just move back to the previous one, please? It can be used for news, of course, but not only. We start having more and more users who are using smartphones for multi-camera production. So you can deploy 3, 4, 6 smartphones in the location for the event on tripods, for example, plug mics and audio, and have an audio mixer, for example, send all those feeds to a remote studio and do remote production without any specific hardware equipment on site. Last piece of a software-based solution is a live guest. You probably, especially with COVID, have been looking to invite remote guests from their office or from their home into your live program. The previous app I was mentioning is more for professional, for cameraman, because you can do white balance, ISO, manual focus, and your guest is probably not an expert in broadcast and video production. So we have another solution which is called Live Guest. It's a WebRTC solution, so it means your guest doesn't have to install any software. You, in the studio, you will just create a link that you send to them over WhatsApp, text, whatever. And when they open it on their smartphone, tablet, laptop, it will open in their web browser, and they will be live in your production. They will be live on your production, but they will have intercom, so you can interview them. They will have a video return you can send them from the studio, so they can watch the program, or more often what you will like to do, you will send them the fixed camera which is shooting the presenter, so they can talk with the presenter without being disturbed by the final program, this kind of thing. Then that's another part. I've been mentioning a lot about the field, but what about the studio? About the studio on the other side, you will have some receiving platform. So if you have a physical studio, I will speak about the cloud later, but we have a solution called the Stream Hub. The Stream Hub is a receiver, decoder, and distribution platform all in one. It means all the previous equipment I've been showing to you, the bonded cellular solution, the fixed SRT encoders, the Mojo Pro for smartphone, and the Live Guest solution can all connect to the same Stream Hub platform. It's a 1RU server that you set up into your studio. You connect to a broadband internet connection, and you can have up to 16 live input feeds coming into the platform from all the equipment I've been mentioning, but also from third-party equipment. So you can receive SRT, RTMP, HLS, NDI into the same platform. And then that platform is giving you outputs, of course. You have SDI outputs, NDI outputs, IP outputs, ST2110 outputs, up to 16 of them. And you have advanced capabilities, so you can record, playback, transcode as well your feeds from HEVC to H.264, from a bitrate to another, from another resolution as well. So if you're receiving an HD feed but you need an SDI output, it can transcode that as well. And you have all, of course, the monitoring and control capabilities through a web-based interface, which is very easy to use. If you are coming on our booth, I will show you the workflow. It's web-based. You see all your inputs on the left side and your outputs on the right side, and you can just drag and drop which input you want to send to which outputs. It's supporting all kind of resolution from SD to 4K UHD. Here you see the web interface where you can monitor and manage all your devices and stream from your control room, or if you are working from home, you can access it remotely as well, for example. Here you have a quick summary about all the protocols that the StreamUp platform is supporting. So you can see as inputs, I've been mentioning them already. The SST is our bonding protocol. SRT, you are well aware. And all the others are standard IP protocols, including NDI. And we are supporting the same on the outputs. We also have a specific StreamUp version with SMT2110 output if you are moving your studio from SDI to a full IP uncompressed video. So that was a physical studio, but will the future be more in the cloud? Probably for some parts of the production. So we have more and more cloud-based production platform, which you might have been trying already. And our technology is designed to be able to feed them with live feeds from cameras. So if you are producing in the cloud with no physical studio, using platforms like Grabio or Blackbird, for example, and accessing them just with a web browser, you can use our product over cellular or landline with SST or SRT protocol to send your live camera feeds into those production platforms in the cloud. And then you can have all your production team accessing through web browser and doing the graphics, the production, the switching. So to finish with, I wanted to show you some real customer use cases to show you example of how it has been deployed and how it is being used already. So the first one is content sharing, live content sharing. That's, there is an association called Les Médias Francophones, so it's French-speaking stations. There are some in France, in Canada, in Africa as well. And they were historically sharing 24/7 live content between them over satellite. So each of them were having a satellite uplink, satellite downlink, and they were receiving content. At that time, when they did this project a few years ago, they were just sharing an SD channel between them, and that's all. And it was costly because it was 24/7 over satellite. They decided to move to IP thanks to our technology, and now they are streaming multiple channels in HD quality each, and each of them can grab whatever live stream they need. It's much more cost effective because here they are all using the existing public internet connections they already have in their studio. And it's much more flexible because to deploy that, they just needed to set up those rack mount encoders, connect them to the internet, connect the SDI inputs, and that's all. Same for the decoding side. The next workflow I want to show here is for sport production. So that's an example with Gravity Media covering running a triathlon race. So what they've been doing is that they have been having fixed cameras at the starting line and fixed cameras at the finish line, but they were also having on the move cameras on motorbikes. So they have been combining all the HAIVISION technologies here, having Makito X for fixed encoders at the start and the finish over landline internet, and having bonded cellular mobile encoders on the bikes. All the feeds were being received remotely in a remote studio. The production was done there, and then it was SRT distribution over IP and satellite distribution over satellite, obviously. So that's another one. Another last one I wanted to show is about 5G as well. So 5G is deploying quickly in every countries, and 5G is really interesting because it's not only to give you more bandwidth or a lower latency compared to 4G, it's also having additional capabilities in the 5G protocol to be able to deploy private 5G networks, for example, to have a quality of service, a dedicated bandwidth, and this kind of thing. So we have been working for a few years with 5G, and all our products now they have built-in 5G modems, and they are supporting all the 5G networks, public and private. And we start having some users deploying their own private 5G networks in a stadium, for example, or in a venue to replace wireless solutions like microwave or Wi-Fi, which are not as flexible and as robust as 5G. So here it's an example in Greece. They wanted to showcase 5G for remote production for a football game. It was a Greek Cup final. So they wanted to show a full remote workflow, as I've been mentioning earlier. So they were having PTZ cameras in the stadium, our 5G video encoders, and they were receiving in the remote studio. So the units, the mobile units, were doing at the same time the live video transmission and the camera control. Another example I didn't mention here, but you might have seen the coronation in London a few months ago. It was also produced live by the BBC over private 5G networks. So they have been deploying a private 5G networks across the avenues in London with multiple private 5G cell towers, and the feeds were received in the BBC studios over the same private network with an ultra-low latency. And that's the future of what 5G is allowing, because they were sending 4K UHD, 4210 bits at 80 megabit per second HEVC with a latency end-to-end at 80 milliseconds. So that's on the move. So that's really interesting, and that's what 5G is offering as well. So thank you for your attention. Just before we go to questions, if you want to receive that presentation and slides, you can add my phone number on WhatsApp. You can maybe take a picture. This is my phone number. It's available on WhatsApp. You can send me a message, and I will be pleased to share the presentation with you. For questions? Yes. Okay.
All right. Thank you very much, Florian. Do we have questions? Okay. Now, if we want to ask questions, I'm waiting for people to stop. The man that delivered the thing is here. That is what you are focusing on. You should take pictures of him. Yeah. No, I'm kidding. Questions. How many questions do we have? How many? That's one here. Okay. So is that just the one? Like the other guy, it's going, gone. One question for you, my friend.
Thank you very much, sir. My name is Amina Mohammed of Ames Media. Thank you for a very robust and wonderful presentation that we practitioners really need. I'm more interested in your backpack. When I was in public service, that came to fore, particularly when you want to collate election happenings in the Federation. But since then, I don't know if where I worked, that is the NTA, if they eventually got. So I'll probably be talking to you on that. I'm also quite interested in the way you have talked about your digital equipment. You know that I'm sure you're familiar with our broadcast system here in Nigeria. As much as we produce digital content and you take to some of our broadcast stations, they still operate analog. So you have to scale down. Do you understand? So I don't know how we're going to match that. More importantly, and pointedly too, very robust equipment you have. Do you have training program? For instance, if I have a personnel that I want to acquire your equipment, and I need for that personnel, my team members, to be abreast with the technicalities of the equipment. Do you have such provision that you can provide here in Nigeria, not necessarily have to travel to where you are? You know, I actually have been interacting with your people since the last Africast in Abuja. So I've just interacted with them before your presentation here. So then, this issue of, I'm happy that you talked about internet connectivity, where you can use 2 service providers at a go. But you also know that anything that is based on internet, particularly in this our climate, has a natural weather to contend with. Would we be able to, take care of that? Then I'm just curious. You talked about the functionality of our smartphone. I'm wondering if that won't demarket your equipment. Because for now, yes, some of us use it. When we have to travel abroad and we don't have any personnel with us, we rely on the smartphone to collate content, and it's good to go, you know. So the other last one is the issue of the decoder and the streamer that you said can be compact. And finally, sir, if you say that we can operate or transmit in a miniature or compact environment, do you have equipment where if you have to operate a TV station, for instance, that can take care of a smaller space where everything, you collect content, even if it has to be live, outside broadcast, collating content just like you showed us, and then not necessarily wide that we have now for analog. Can we have that? Can we have that synergy? So those are my concerns. Thank you.
I think I need to take that list you wrote down, because I don't think the man will remember all your questions. Did you make notes, Florian?
No.
So I will help you. So the first one is backpack.
I think I remember most of them, and I've been listening carefully, and those are really accurate questions in many different topics. So the first one about backpacks, you are more interested in our backpack solution. I've been showing some of the products which can be carried in a backpack. It's a small device which is really high quality, and if you have been using bonded cellular in the past and you have been facing in some situation some freezes or some issues with the transmission due to the cellular network, the technology that we are having here is embedding high-gain patented antennas inside the backpack, which are performing better than standard antennas and standard modems. So we got numerous feedbacks of our users who were telling us, oh, I've been comparing your solution with other bonded cellular solutions. And when I was in a stadium or inside a conference hall with a lot of smartphone users, with the other bonded cellular solutions, we were experiencing freezes or even disconnection, and sometimes we have to move the backpack outside the venue and run a long SDI cable. With this solution, it will work, and they were telling us, oh, your solution was working inside at the same place, same venue, with the same SIM card, same latency, same camera. So it's really, you have different bonded solutions available on the market. They are not all the same. And the criteria is not only the number of modems inside, it's also the quality of the antennas, of the encoder, and of the bonded cellular protocol which is being used. So that was the last one. But I can do them randomly and yeah. Yeah. So about training, we are offering training on site in Nigeria. So we have a dedicated training team of engineers specialized in all our equipment, which can provide dedicated training. And it's really dedicated to your workflow. So if you are purchasing some of our equipment to do news, you will have a total different training than if you are doing remote production for sports, for example. They can travel here. They can stay for multiple days, train your team. We also do dedicated training depending on your team members. So some might be interested in the camera bonded cellular units, but they don't really need to understand what's going on in the studio, and the opposite. So we can do multiple sessions, and it can be one day for more camera operators, one day for more studio operators, one day for administrators, for example. So we can do that. Apart from the training with our dedicated support engineer, we also have a local partner here, a company called Highway Audiovisual, who are experts in our equipment as well and can provide support and training locally as well.
Yes, Florian, then you have, how do you match digital production to analog transmission?
Yeah, so that's a good question as well. So if you need, for example, here it's mostly digital with SDI inputs, SDI outputs. If you have analog cameras, you will need a converter from analog to SDI, and same thing at the studio. But it's possible. In terms of resolution, I've been mentioning HD, 4K, but we support SD resolution as well. And what's interesting and flexible is that maybe sometimes you need an SD output for some of your channel, but you will still leverage sending HD to YouTube because you have been producing with HD cameras. So that's possible as well, and that's the beauty of it, is that you can distribute your content in different qualities to different destinations.
Then software for phone.
Yeah. Yeah. Yeah, so I think, if I understood well, the question was, will smartphone replace cameras and the hardware transmitters? Partly, yes, partly. It's already happening. I can give you an example of a 24/7 news station in France who is using hardware cameras and transmitters for the national channel, but they have been launching some regional channels for regional news, for example, in the Paris region, and from scratch, they designed the channel to be entirely produced with smartphones. So they have been training their journalists, they have been purchasing some latest iPhone or Android, some tripods, some special mics, they have been testing it. They have been designing some kits adjusted to their needs, and they have, I don't know how many of them now, but they have multiple kits that their journalists are trained on, and it's nicknamed the one-man journalism. It means they can set up the equipment by themselves in the field. It's in a small backpack. They can view themselves from the phone. They have a earpiece for the interview, and they can be live on air, an interview for news, for example. They also use the smartphone app to record content and produce content. I haven't been mentioning it, but in the Bojo Pro app, apart from live transmission, you can record content, and then you have some functionalities to edit your content. So the journalist can be live during the news hour, for example, and the rest of the day can record content and edit it, and you can create projects adding multiple recorded clips, crop them, add some voice-over commentary and some graphic as well, and then send that material to the station for post-production.
And I think the final one is streamer versus decoder in one. Yeah?
Streamer version?
Streamer and decoder in one.
Ah, yeah. So what's interesting is that you really need, over the time and in the future, or even today, consider merging between traditional television, online streaming. Potentially, we see more and more radio doing video as well for the social media, and trying to merge the departments into a single production environment. So in a solution like the Streamer platform, you can output SDI into your production, you can output MPEG-TS to a modulator, a satellite modulator, and you can output SRT or RTMP to YouTube, Facebook, and so on at the same time. So that's interesting to distribute your content over multiple platforms.
Awesome. Thank you very much, Florian. And any other question, actually? Maybe. Okay, go ahead.
Now, the question I want to ask is for the iPhone, I mean for the smartphone, that's using the smartphone now. If I was to use my smartphone, that's use your software now. Back at the master control room, do I need your device, as in like your server, or there's a software I can actually load onto my own system back at the master control room to receive signals now from the smartphone on the field?
Yeah, very good question. The answer is that yes, you will need a specific receiver at the station because the transmission from the smartphone is using our bonding protocol called SST, so you will need a compatible receiver for SST. If you don't need a hardware receiver because you just need an IP feed, for example, or you just want to send the feed to the cloud, it can be a service in the cloud or it can be virtualized. But if you need SDI or NDI output into your production, you will need our receiver and decoder. Yeah.
Okay, any other question? Okay, now, any other question after this man? Okay. So if I don't take another question, don't blame me, yeah? Any other question after this gentleman? All right, you go, sir.
Yeah, good afternoon. So my question is, in terms of entertainers, we've got series of music performance, live music, virtual music performance. Can your software or device, can it be able to manage something as that? Like music performance, you know, there's a lot of technicalities when it comes to music performance, sound engineers and everything. They have to have their part. So now, can your service, can your company provide something like that for entertainers? Like we want to do virtual performance to people probably in Europe, Asia, other countries. So do we have all those plugins that can carry the work of entertainers, like say musicians too?
Thank you for the question, because it's something I didn't emphasize much in the presentation. Yes, it can definitely be used for entertainment, music, concert, and it's a high quality video and audio transmission here. If you are familiar with bonded cellular for a long time, you probably know that 10 years ago, bonded cellular was mostly used for news, breaking news, because the quality was quite low and the cellular networks with 3G was quite low. So it was mostly for breaking news, but the quality was not good enough for sport or the entertainment. This has completely changed. This has completely changed, and with our technology, you can encode and stream a feed up to 4K UHD at 80 megabit per second, HEVC for 2 to 10 bits with HDR. So it's definitely capable of providing you a very high quality for both video and audio. And we got more and more examples over the past few years of some of our users who have been comparing also